Hey, what's up guys? This is Krishna here. Welcome to this project walkthrough of Vellum Balloon Pop. Now, I did a video a few months ago called Vellum Fluids, and one of the videos in that one is a balloon pop along with fluids. This is pretty much a similar setup here, and this file I'm going to go through today. I submitted this for Side Effects Challenge Houdini. Okay, let's jump straight into it. But before that, as a matter of fact, this file is available for free to download on gumroad.com. If you feel generous, you can donate towards that file, but it is available for free. Okay, so first I've got a bunch of containers here. Okay, Vellum Source, Render, Vellum Balloon, Vellum Fluid, Collision or Collider, and then Grid. Okay, so Vellum Source is where actually everything happens, so let's jump right in. So I've got a test geometry, big head, okay, and I've scaled it to 1.2 and translated in 1.5 in the Y position, okay. And then I'm Booleaning, Booleaning, I suppose, that, just in case if you got any problems, I'll make it one solid piece, basically. And I created this switch originally to add more sources, and I wanted to try it out, but I don't need this anymore. And I'm subdividing that, okay, just by one depth, and then we've got a balloon set up here. Okay, so let me just pull this up a little bit. Okay, so I'm fracturing it, edge fracture. Okay, but edge fracture means that it'll only fracture, there are no inside pieces. It just fractures the outside, and if I select that, as you can see here, that's what is going on. Okay, and I am creating a new point group called tear because we're going to use that later. Okay, just creating a null, GA1, and if you drop in Vellum Balloon, it comes up with these two nodes here and Vellum Cloth, and I'm just going to open that up on this side here. So if I select that one there and this one here, see, they should be pretty much identical and their default values. Okay, I think except for the stiffness. Okay, so this is what I have configured. This is the default here on the left side. So the default stiffness is 6, and and it's 100, but I increased the stiffness a little bit. So this is 600 technically, and this is 1000. And I reduced the damping ratio to avoid any jitter. Okay, that's what that is, and nothing else. Everything else is the same. But I'm now using Vellum Stitch in between. By default you only get these two nodes, but we have a geometry that's broken up. So I'm using Stitch to connect these points, and I'm using that tear group which we created earlier from the edge fracture, and I'm basically stitching that tear group, as you can see here. Okay, these little bubbles here or dots are the ones that are connecting it. Okay, and if you go further, I've given it a million stiffness and reduced the damping ratio as well, or increased the damping ratio actually. And I'm selecting output group as tear stretch because we will need this for later. And I'm also enabling breaking threshold at 1 with stretch stress as the type. Okay, that's good. And moving on to, I'm just going to move on to this side actually. It's more comfortable for me here. So again, pressure constraints, I have to choose this one. So by default, which is on the right hand side now, okay, so these are defaults, and the stiffness for the default one is 6, which is 600, and the one I created, I increased the stiffness significantly compared to the default. So this will be 1 million, and the damping ratio is higher because I don't want any jitter problems. But notice the rest length scale is 2. This is what blows up the geometry, making it appear like a balloon, So I've given it a rest length of 2. Okay, so as soon as the simulation starts, it will just blow up. Okay, not blow up as in pieces, but it'll be still a one piece geometry, but it'll just look like a balloon. Okay, I'm also selecting an output group called P stretch, which is pressure stretch. Okay, didn't want to type too many letters, I guess. All right. Okay, so let me just delete these two here. Next, I am creating two nulls. One is constraint, and then this one will be our geometry. Okay, and then I'm feeding that into Vellum Sim. Okay, but before I go into that one, I just want to go through the one on the right hand side here. Okay, so this is a Platonic soccer ball. Okay, and I poly wired it. As soon as I do that, I get this one. So it's kind of, I wanted to confine the pig inside of it, so when it blows up, it kind of interacts with this thing and goes through it, etc. So that's what that is. And then on the right hand side here, I have created a collision source with a voxel size of 0.04. Okay, and I'm not sure what I'm deleting here. It says group 9. So there's something going on here. Yeah, so there is some sort of problem here. Okay, so I'm deleting it, and then the problem comes up. Ah, great. Okay, maybe I shouldn't have it then. There you go. Okay, I removed it. All right. All right. So next is the collision source, which I already talked about. Okay, good. And I'm creating a null here called collision because this is what will be fed into our simulation. Okay, in here. If I were to use Vellum Solver straight in here, this input is what we will use. Okay, but because I've created a DOP network, this is the input we will be using. Okay, so I'm going to get rid of that. So technically you don't need that, but I'm going to leave it in anyway. So on this side here, I've got a fluid set up. Okay, so what I'm doing is I'm reducing, I'm basically making a smaller version of the pig head. Okay, and then I'm creating a sphere just with this parameters here, and then I'm matching that size so it sits in the center of the pig. Well, I suppose I didn't need to do this, but anyway, I think it's to avoid the problems that may occur here. But anyway, basically the point is to place this sphere right in the middle of the pig head. Okay, that's the idea behind it. And then I'm creating a vellum fluid, and this one, these are the setup because this is what I figured was the best settings for this particular setup. The important thing here are these things here. So the viscosity, surface tension, friction, dynamic friction, everything has been increased because I wanted to interact with the balloon so much that when the balloon explodes, the fluid within it also gets splattered. That's the whole idea behind it. Okay, which is very prominent in the other video. And in this particular video, it isn't that prominent, but you get the idea. It's the same for both setups. Okay, so they are the setups here. Okay, so you can obviously grab a copy of the file and have a look at it. And then I move on to geometry, create geometry and constraint nulls. Okay, because these are Geo1 Con 1 and Geo2 Con 2. Okay, so let's dive into the Vellum Sim itself. Okay, so we got a bunch of stuff here, so I'm gonna have to go through that. So first is our Vellum balloon, which is our Geo2. Okay, so if I remove that, that goes away. There it is. Okay, and then the one on the right hand side is Vellum fluid. Okay, and then I'm merging them two, and let me just get rid of that for the time being. Let me run this now. Okay, because I want to be able to explain what's going on here. Okay. But also, let me just go through this here. So this is our Vellum object, which we need. And then my static object, which is the enclosure here. Okay, so there, that one. Okay. And then I create a ground plane. All right. So that's that. And Vellum Solver itself. Just the typical stuff. Substeps I increased it to 5. And these are default. And in advanced, what did I do here? All of these are default. Oh yeah, okay. So I disabled enable mesh shock, and this was giving me a lot of trouble when it comes to the jitter problems and stability. Okay, so once I disabled it, it was a lot better. Okay, so that's why I did that. Everything else is pretty much default. Okay, so let me run this and I'll come back. Okay, I ran about 9 frames and you can see it's already just fallen apart. Okay, as you can see, it's just let me just get rid of that for the time being, and that as well. Okay, if you click on this icon here, it just hides it. It doesn't disable it. Okay, if you click on this, it will disable it. All right. Okay, so as you can see, it's just falling apart straight away. That's because it's not holding on to the torn parts. Okay, so first thing is I want to introduce this one here. Okay, this break here, because remember on the outside what we have done here is we have said if you go above a breaking threshold of 1, break it. Okay, and that's why this is breaking apart straight away. Let's say, for example, if I uncheck this and let's play it, there you go, it's not breaking anymore, you see, but it's gone all wobbly, whatever. But anyway, so that's the reason why that is in there. But you know what, I'm actually, on the hindsight, I think I might have left this on by mistake. I don't really need it because I'm breaking it in here. So I'm going to enable this and then let's have a look at it. Yeah, so yes, that's exactly what I'm doing. Okay, fine. So we don't really need this, so I'm just going to set this back to default. But it doesn't matter. I mean, even if it's enabled, it doesn't matter. Okay, so I'm going to leave it enabled. Right, so what is happening here? First of all, I'm breaking it just for the tear stretch group, which we created here, okay, in the Vellum Stitch 2 constraint. And what I want to say is I want the break threshold to be 1 here, which I enabled. However, I'm using the expressions, and I'm saying if the frame number is below 48, your break threshold will be -1, meaning you will not break. Else, your break threshold will be this channel, okay, which is basically 1. You can increase or decrease it depending on your material and depending on your setup, you know, stiffness and whatnot on the cloth and pressure constraints. Okay, but that's what that is. So after the 47th frame, it will switch the break threshold to this. Okay, so if I enable that now, in fact, what I'm going to do is I'm just going to bring this down to, let's say, 10, okay, just to try it out. So I'm going to run this now, and let's see what happens. So that should really break after the 9th frame. There you go. So as you can see, at the 10th frame, or at the 11th frame, it started breaking. There you go. So that's the idea behind it, okay? So I'm going to put this back to 48. And now let's move on to the next one. Not that one, this one here, okay? This is a little trick I figured, okay, which was really cool. So ideally, what is happening here is that the rest length scale, what we set up outside here for, I believe, the pressure, yeah, so that is set to 2, okay? However, what we need is this to blow up even more. The rest length scale of 2 is what was playing earlier, which blew up the pig a little bit, okay? And if I were to say this was like a 100 or something, you'll notice that okay, it doesn't like it before it crashes. 40 maybe. Okay, so let's check. Yeah, there you go. So it's blowing up significantly. Okay, so anyway, I'm just gonna put this back to 2. Okay, and what I'm doing here is the fact that I am saying, okay, I basically keyframe this. So if I look at the keyframes, which is, yeah, there. So hold on Shift and middle click. It'll open up this. Press F, G, H. So there you go. So at the start, you gotta drag and select this point, okay? If you just select the point, sometimes you won't get the options, right? See, like this one and this ones are all grayed out, but if you drag and select it, you will get all these options, which I don't know why, but that's how it works. So at frame 1, you got a value of 1. On frame 48, we got a value of 100. Okay, so I'm gradually increasing this rest length to 100, so the balloon just blows up. Okay, and this part you have to animate, unfortunately, but once you figure out which frame you want to pop the balloon at, you set the rest length scale to 100 at that exact frame. Okay, let's say for an example you want to do it at 72, then you set that to 72. Now, I've said, okay, rest length scale increases, and it only applies for the pressure stretch group, okay, and not for anything else. Alright, so let's run this now. It'll be 48 frames, okay, so I'll have to come back. Okay, it's done the 48 frames, or even 61 frames actually, so let me run it now. So as you can see, it's breaking just after the 48th frame. Okay, it's breaking apart, which is beautiful. Okay, and I obviously disabled this here, so I need to go back out and let me enable it here so we can see the whole lot. So, bam. Okay, that looks pretty good, I think. So, let's move on to the next part, which is, actually, you know what, before I forget, let me just double check here. I want to just double check something. I forgot to mention this. So let's say you want to pop the balloon at 48. You're going to set your rest length scale to 100 at that point. Okay. However, 2 frames later, I am bringing it back down to 1, and that's imperative. Okay. And the reason behind that is because you notice here how at 48 it breaks, but then it starts to shrink down, just like a balloon will do. You know, when it pops, the balloon shrinks back to its, you know, kind of a normal state because, you know, it's elastic. Or it's a balloon, you know, at the end of the day. So, if I don't have this particular part where, let's say I go ahead and delete this at frame 50, okay? I'll delete that. Okay, let me run it again, I'll come back to you. Okay, so I got 2 flipbooks for you. Okay, so this one is where I do not bring the rest length back to 1. Okay, so let's have a look at it. You see how after the 49th frame, it's just staying as big they are currently? Like, you know, the rest length is 100, so it's just taking to 100, okay? But watch this one. Wow, that's a significant difference. Now this trick is probably hard to imagine that, but anyway, it's a nice little trick, which now the balloon behaves like a balloon once it pops, because it brings it back down to rest length 1. Okay, so hope you like that one. Alright, so let's move on to the next part. Okay, and the next one is this Vellum constraint attached to geometry. Okay, so I'm just going to enable this now, and this goes to stream vellum fluid, okay, which is this one here. Okay, I mean, if you want to attach balloon as well to the collision object, then you know you don't need this. But I wanted to attach just the fluid, okay, because I think the balloon will automatically you know, just hold on to it and whatnot. I don't want it to stick to it, you know, but I want the fluid to stick to the collision object. All right, so let's see, where's the static object there? Okay, so that's why this is here. Okay, and then I'm saying, right, the target path or the target geometry where you want to stick to is the collision source 1, which is here. Oh, collision source 1. Okay, and that's based on the voxel size of 0.04. Okay. And I've also said that you got a max distance of 0.05. Otherwise, what will happen is that it'll try and attach the geometry even before it's nearly there. Okay, so for an example, I'll just show you here. Right, well, I'm attached to geometry, that, and that. You see how the geometry is attached to the collision object straight away. And if I enable max distance, there you go. So I set 0.05. So, which is basically, let me just try and increase this and see where 1.25, it starts to attach itself. We don't want that, okay? So basically, what I'm saying is when you get really close at a distance 0.05 or below, then you get attached to the collision object, okay? That's the idea behind it. So I'm just going to undo everything I did here. Okay, good. So that's what that is. And then I think this default stiffness here. Nothing else to change here, okay? However, it is each frame. Okay, so each frame you're gonna look at where you are at and then attach this geometry or yourself to the collision object. Okay. What about these ones? These are fine because they are constraint properties, and this is constraints. Okay, so big difference. All right, I'm gonna run this again and I will come back. Okay, so I got 70 frames here. Okay, so let me run it. By the way, this is extremely prominent in the other file where it attaches itself to the class box. Okay, but at this one, the collision itself has a lot of holes, so you know it's not that prominent, but it certainly works. Okay, so let me show you. So there it is. Okay, so and the reason why I'm at this angle here is because of these particles. Okay, these like 1, 2, 3, 4, 5, 6, 7 particles here. See, so it hits at 68th frame and just sticks to it, and this one hits at 72nd frame and it kind of sticks to it. All right, and at the bottom here as well, as you can notice, they're sticking to the collision object, which is exactly what I wanted. And that reminds me, the example I showed you earlier outside here, this was not meant for the pig head, but it was meant for this one. So if I were to say Vellum attach geometry here, so points, there you go. You can see it's straight away attached to it, okay? And that's why I had to use max distance. All right, so anyway, that's what that is. Okay, good. Right, so that kind of finishes the Vellum sim itself. So we've done that now. Now let's look at the actual fluid itself. Okay, so on the right hand side here, I believe I'm isolating just the Vellum fluids. Okay, so it's inside right now, inside of the pig head. Okay, look how it behaves. So it's actually interacting with the pig, expanding or ballooning, and then when it explodes in the 49th, 50th frame, you can see it's starting to respond to it pretty good. It's being thrown apart because of the high friction values. Okay, but you can try it out. You know, you can change it and see how it behaves. But basically, that's what is happening. Okay, let's look at what's happening after the simulation here. Okay, so I'm isolating balloon and I'm isolating the fluid itself. As far as the balloon is concerned, I tried to use the point deform, connect it to the original and see how that worked, and unfortunately I ended up with this problem here, so I decided not to use it. Okay, so it's just coming straight out. Okay, and then it's going through Vellum post process. Okay, in Vellum post process you can see that it looks pretty neat here. Okay, but before the post process you'll be able to see this seam, the edge tear seam. Okay, and that's what I'm trying to eliminate, and using Vellum post process I was able to successfully eliminate that seam. So we've got a subdivision depth of 1 using loop subdivision, and then detangle and pass. Okay, that's what that is. And then I'm using a normal, and then I'm applying a material. As far as the fluid is concerned, I'm just going straight to, so both of these are currently assigned to cage, which is not right. Let me just have a look at the material. Okay, so I think this needs to be fluid. Okay, so that'll be our cage. Okay, that's good. And then for visualization, I've just created these things here. Okay, nothing, it's not a big deal really. So out will contain all of it, including material. Okay, but I think I'm actually using materials properly out here in the render containers. Okay, so inside the render container, we've got Vellum balloon coming in. because I have to isolate it again because I merged them all. There's the outsim. Okay, so I'm just isolating it. Well, maybe I shouldn't have done that. I should have just called them null here. Okay, but it doesn't matter. I'm going through post-process one more time, and that's because I'm actually pulling it from here. Okay, and that's why I need to go through this post-process again, but this time I'm using subdivision depth of 2. Okay, and I'm extruding it by thickness as well. Okay, and then I'm creating a normal. So technically none of this is required. And then I'm creating, I'm isolating fluid and calling it out fluid here. But this, yeah, the render flag is set for this one, so that's okay. Render fluid. So I'm bringing in the out fluid from the render container. And what I'm doing is I'm switching the input after a certain frame. Okay, so if you're less than 49, because we're really breaking it at 48, so I don't need to see the fluid inside the balloon until then, because especially this material for pig isn't a see-through material, so we don't want to waste time calculating all this jazz here until it is 49th frame. Okay, so that's why I'm doing this. Until 48 there'll be nothing, and then 49 it comes up, whereby I'm creating a pay scale attribute where it is based on the particle separation. Okay, where does that come from? I believe this one here, and that particle separation comes from the Vellum source fluid 1 grain size. Okay, this grain size. All right, that's what that is, and then I'm multiplying it by 2.25, and honestly I don't remember why, but let me see. Yeah, it was too small. That's why. Okay, good. And the voxel scale, influence scale, and everything is connected, and they all have their own scale values as well. Okay, because I didn't want it to look awkward, you know, because at a small scale, this can go really bad because it's only to 0.06. And then I'm creating a VDV based on that, and then reshaping that with erode, and then I'm smoothing it out, and then I'm converting it back to polygons. I'm transferring velocity attribute from the mainstream into the fluid, and then I'm rendering it out using a material RS fluid. In this place I've allocated or mapped the right material. That's why it worked in the first place. Render collision is just basically a Vellum source collider that comes in, which is this one here. Okay, and then just adding a normal and assigning a material to it. Render grid, a simple thing, grid, and then converting it to polygons because I think it's NURBS. Let me just double check why. Usually what I do is I make it like a backdrop, but I didn't do it this time, so I could have just left it as polygon here, but anyway, it doesn't matter. Creating a normal and then assigning a material to it. Okay, so let's move on to the actual material itself now. So pig is coming from a texture sampler. Okay, and this is very interesting, and this is a trick, if you want to know. To render pig material in Redshift, you need to use this definition. Okay, sorry, function opdef colon sub. These are all available within Houdini installation. So all you need to do is type in that, and it'll pick up that file. Okay, but if you middle click on the file name, usually it shows up the actual directory. But with this, in this one, it doesn't. But I promise you, it's there. Okay. And then specular, and then I'm getting the subsurface scattering. Okay. So yeah, all this jazz here. Okay. Next is the fluid. Fluid is basically water thing, and then I colored it yellow, and I think nothing else really changed here. Okay. So that's the fluid, and then the cage is iron. That's basically it. So you get a bunch of presets here, so maybe they should, Redshift, Maxon should add more presets here, but anyway. So that's that. and grid is lead. So that's about it. And as far as the camera is concerned, I have enabled depth of field with a sampling of 0.08, and then I have a focus distance which I animated over time. Okay, so as you can see, it's animated first frame, 19th frame, 24th, 48, and 54. Okay, so just depending on where a particular part of the peg was, and I think I just did that. That's that, and it's a 1080. The focal length is 85. Okay, and that's that. Light Dome. This is Photo Studio. I believe this is also available for free from polyhaven.com. I'll leave a link in the description so you can check it out and download it. Okay, I think that's about it. Let me just double check if there are any. No, there isn't any, post or compositing work. I was just testing this out to see if that works, and it does. So that's that. Okay, so I hope you enjoyed this video. I hope you learned something from it. If you did, give me a like, thumbs up, comment, share, subscribe. I really appreciate it. Thank you for your time, and until next time, have a great day.